surface integral of vector field. Previously, we have learned about the line integral. So you know the line integral only involve a single integral. So today we will look at the surface integral. So a surface integral is about an integration of function over some surface S. Okay. Okay, let's say you have this surface. Okay, surface S. Then you want to find the integral of this surface. So by using the surface integral, we can find the amount of vector flowing through the surface S. So if the vector field F, this is a vector F here. We have a vector F here. Represent the flow of a fluid. Then the surface integral of F will represent the amount of fluid flowing through the surface. So sometimes you call a surface integral as a flux integral. So this is the definition of surface integral. Let F, this F is a vector field. Then the surface integral or a flux can be written as double integral F dot ds. This is equal to double integral F dot n ds. Where n, what is n? N is the normal vector of surface. We have two types of surface. The first one is the parametric surface and the other one is the non-parametric surface. So parametric surface is a surface that is not represented as relationship of x, y and z. For example, cylinder and sphere. For sphere, can be represented by x equal to r sine theta cos phi, y equal to r sine theta sine phi, and z is equal to r cos theta. And for non-parametric surface, this surface is represented as a relationship between x, y, and z. For example, a circle. So x squared, y squared is equal to 9, where this is r squared, the radius. So the other example for the non-parametric surface is the paraboloid, triangle, or the tetrahedron, ellipse, and cuboid. So this is some of the types of parametric surface, cylinder and sphere. And the non-parametric surface, we have a circle, ellipse, paraboloid, cuboid, and tetrahedron. For parametric surface, how to understand the question? Let's say you have a cylinder. For example, the surface S bounded by x squared plus y squared equal to 25 and z is from 0 to 4. The radius of the cylinder, okay, so this is the radius of the cylinder, r squared is equal to 25. So your r is equal to 5. And your z is the height of your cylinder. So let's draw this. Here you have from 0 to 4. Okay, this is your z. Okay, so this is 0 and this is 4. And the radius here will be 5, 5. So this is cylinder. So in this example, z is from 0 to 4. Let's say you have z is from 1 to 5. So your cylinder will be like this. Okay, here is 1. This is your cylinder. 1 to 5. The height of your cylinder will be here. Okay, 1 to 5. So another example for parametric surface is the sphere. Surface S is bounded by sphere x squared plus y squared equal plus z squared equal to 4. So you can see here your r squared is equal to 4. So your r will be equal to 2. R is your radius. So you can draw your sphere. Your r here will be 2. Okay, the radius of your sphere is equal to 2. So for non-parametric surface, you have a tetrahedron surface of Z equal to 6 minus X minus Y. Okay, so how to draw your tetrahedron? So to find the point at Z-axis, okay, so X equal to 0, Y equal to 0. Okay, substitute into this equation, you will get Z equal to 6. Okay, so Z here will be 6. And then for y-axis, X equal to 0, Z equal to 0. Then you will get Y is equal to 6. So here will be 6. And for x-axis, Y equal to 0, Z equal to 0. Then you will get X is equal to 6. Here will be 6. And then connect all the points so you get your tetrahedron. So this is your tetrahedron here. So you just substitute x0, y0 into this equation of tetrahedron. So x0, y0, you will get z is equal to 6. So here z equal to 6. Similarly, for x and y axis, you just substitute y equal to 0, z equal to 0, then you can get your y. If z equal to 0 and x equal to 0, put here 0 and 0, then you get y also equal to 6. And for x axis, substitute y0, z0. Okay, here y0, z0, then you will get x equal to 6. 6, 6, 6 here. Then you connect all these points, get the tetrahedron. Okay, so now let's move to the paraboloid. Okay, surface Z 4 minus x squared y squared. Okay, above xy plane. So above xy plane, this means Z is equal to 0. Okay, so this is xy plane. So Z equal to 0. So this and this give you the same meaning. So you know paraboloid is like this. This is paraboloid. It is different from hemisphere. This is hemisphere. Okay, so this is paraboloid. And this is hemisphere. Okay, paraboloid dia lonjong sikit macam ni. Let's see the equation of paraboloid. You have 4 minus x squared minus y squared. So this 4 is your r squared is equal to 4. So your r is equal to 2. So let's sketch your paraboloid here. So your radius here will be 2, 2. Okay. And the height in the question given, if z is from 0 to 6, then here will be 6. 0 to 6. The height will be 6. Normally, it will be given in the question. So, you can find the surface integral. The formula for surface integral for parametric surface is equal to f dot n ds. So, your n will be a del s over magnitude del s. So, parametric surface is a sphere, cylinder or hemisphere. Okay, that is the types of parametric surface. And then for the non-parametric surface, okay, I have explained the types, the example of non-parametric such as the cuboid, tetrahedron, and then what else we have here? Okay, circle, paraboloid or ellipse. Okay. The formula for surface integral is equal to f dot n dA. So parametric, this is how you find the n. And for the non-parametric, you can refer this table. So you have to look at the given equation. Okay, for the parametric surface, this is very simple. You know, del S is equal to del S del X del S del Y del S del Z, magnitude of del S. Okay, for non-parametric surface, you have to refer table to find your n. So look at the equation given, whether it is in the form of Z, in the form of Y, or in the form of X. And then also look at the orientation, whether it is positive or negative. So if the question give you the equation Z is equal to 4 minus X minus Y. So in this case, you should use this n. Then you have to check whether it is positive or negative. You can use this one or this one. Okay, now let's move to the polar coordinates. Let's say you have a plane, just a plane. So your x will be r cos theta, y r sin theta, and ds is equal to r dr d theta. And then for cylinder, your x will be r cos theta. Okay, r is the radius here, the radius of the circle in the cylinder. So the radius will be your r, and your theta will be the angle from x-axis. Okay, this is your x-axis, the angle here. So your x will be r cos theta, your y r sin theta, your z is equal to z, and your ds is equal to r d theta dz. And for sphere, okay, sphere you have two angle. Okay, theta is the angle between radius and z axis. Okay, this is the radius r, and this is your z, radius and z. So this angle will be your theta, and the radius at the xy plane is your phi. This is your phi. Okay, this is your phi, and this is your theta. Okay, x r sin theta cos phi, y r sin theta sin phi, z r cos theta, and ds is equal to r squared sin theta d theta d phi. So how to solve the surface integral? Okay, this is the formula for surface integral for parametric surface. First step is to find the n, and then calculate f dot n. Okay, just do the dot product. Okay, convert to polar coordinate, whether it is a cylinder or a sphere. So you have to change it from x, y, z to change to r, theta, and phi. Okay, next is to determine the limit. You have to find this limit here. And the last part is to solve the whole integration. Example 1, evaluate f dot ds yi plus zj plus 2xk, and S is the surface of the region bounded by the cylinder. Cylinder between planes z equal to 0 and z equal to 3 in the first octant. So what does this mean as a first octant? Okay, let's say you have a 3D. So this is the first octant, the area here. Okay, the first octant means the X, Y, Z all in the positive value. Okay, so first let's find the n. So you know the polar coordinates of cylinder. Okay, x is equal to r cos theta, y is equal to r sin theta, Z is equal to Z, and ds is equal to r d theta dz. Okay, let's solve this. The first step is to find your n. So n is equal to del S over magnitude del S. So in this case, your S is equal to x squared plus y squared equal to 4. This is your S, surface of a region bounded by cylinder F. So your N will be, okay, let's find the del S del X, del S del Y, del S del Z over the magnitude of del S del X, del S del Y, del S del Z. Del S del X is equal to 2X, del S del Y equal to 2Y, del S del Z is equal to 0, and the magnitude will be 2x squared plus 2y squared plus 0 square root. Simplify this, 2x, 2y, 0. Okay, simplify this, x squared plus y squared square root. This x squared plus y squared is equal to 4. So 2x, 2y, 0. This is equal to 4 times 4 square root. So your n is equal to 2x, 2y, 0 square root 16, 2x, y, 0 is equal to 4. So x, y, 0 divided by 2. Okay, so this is your n. Next step is to find your f dot n. So what is your f? This is your f, y, z, 2x. Y, z, 2x dot with your n, which is x, y, 0 over 2. So your f dot n will be x, y over 2 plus y, z over 2 plus 0. This is your f dot n. So step number 3 is to convert to the polar coordinates. So use the cylindrical polar coordinates. This is the cylindrical polar coordinates. So in this case, your r is equal to 2. Okay, r squared is equal to 4. So your r is equal to 2. Okay, you can leave here. This is your how to find your r. Use cylindrical polar coordinates. So your x will be r cos theta, 2 cos theta. Okay, your r is equal to 2. Y is equal to 2 sin theta. And ds is equal to 2 d theta dz. And z is equal to z. Okay, step number 4 is find the limit for z and theta. You can see from this figure, z is from, also in the question, you can see 0 to 3. Okay, so your z will be from 0 to 3. And how about your theta? Theta only involve the first octant. So the first octant is this part. Okay, 90 degree. Okay, so that's how you get theta is from 0 to pi over 2, 90 degree. And the last step is to solve the integration. Put all the values together. F dot n ds xy over 2 plus yz over 2. Okay, substitute. This is your x, this is your y, this is your z, and this is your ds into this equation. So x is equal to 2 cos theta, y is equal to 2 sin theta by 2 plus 2 sin theta y, and z equal to z by 2. And your ds will be 2 d theta dz. And then your limit theta is from 0 to pi over 2 and z is from 0 to 3. Okay, let's simplify this. So you can eliminate these 2 and 2, 2 and 2. You will get 2 cos theta sin theta plus z sin theta d theta dz. So I want to put these 2 outside and let's solve the first integration. So the first integration involves this part d theta. So when you integrate with respect to theta, just assume that z is a constant. So how to integrate this? You can use the integration by substitution. Let u is equal to sin theta, du is equal to cos theta, d theta. Integrate cos theta sin theta d theta is equal to integrate u du. You will get u squared over 2. So here you will get 2 u squared sin squared theta over 2 plus with the second part here, integrate this with respect to theta, you will get negative z cos theta. So this is from 0 to pi over 2 dz. So we can eliminate this. F dot n ds equal to 2 0 to 3. I want to substitute the lower and upper limit. The lower is 0 and the upper limit is equal to pi over 2. So sin squared pi over 2 minus z cos pi over 2 minus sin squared 0 minus z cos 0 dz. So this is equal to 1. This is equal to 0. This is equal to 0. And this is equal to 1, 2, 0 to 3, 1 minus 0. Minus 0 minus z dz. 2 plus z dz. So now let's integrate again with respect to z. You will get z plus z squared over 2. From 0 to 3. Then you get 3 plus 9 over 2. Minus 0. And substitute the limit. And then 2, 15 over 2. This is equal to 15. Okay, so this is your final answer. This one I cancel out. You just plug in the value into your calculator. Okay, sin 90 degree is equal to 1. Okay, sin 90 degree, cos 90 degree 0. Oh, this one I integrate this value with respect to z. Integrate dz with respect to z. Okay, so integrate 1 akan dapat z. Integrate z akan dapat z squared over 2. So let's move to another example. Okay, look at the non-parametric surface. Okay, actually this is the same thing as the table just now. How to find your n for the non-parametric surface. Example 3. Okay, determine the flux across the surface z. Z equal to 4 minus x minus y in the first octane, given that f 0, -2, -1 with downward orientation. So this is a non-parametric surface. We have a tetrahedron here. So we have a non-parametric equation. So we have a non-parametric equation, tetrahedron, z equal to 4 minus x minus y. When we have z equal to 4 minus x minus y, for this value, you just substitute x equal to 0, y equal to 0, then you get z is equal to 4. So that's how you get this 4. Similarly, for this 4 and this 4. So given in the form of z, so you can refer this part in the form of z, and in the downward orientation means the negative oriented. Just now z is equal to kgxy with downward orientation. For downward orientation, your n is this part. Okay. Del z del xi plus del z del yj minus k. Surface integral f dot n ds equal to f dot, this is your n, del z del xi plus del z del y j plus k ds. So what is your f? Okay, this is your f. 0, negative 2, negative 1. So 0, negative 2, negative 1. And dot with your n. Your n here. Del z del x. Okay, look at this z. Find del z del x is equal to negative 1. Okay, differentiate this z with respect to x. So you get negative 1 here. With respect to y, you get negative 1 plus k. Negative 1 and k is equal to negative 1. This is minus. Okay. Minus k. So, this part you have to differentiate. This part you have to differentiate. And this part you just put the value negative. Dot product, the first component with the first component, 0 times negative 1 plus negative 2 times negative 1 plus negative 1 times negative 1 s. This is 0, this is 2, and this is 1. So, answer will be 3 ds. Okay, the first step is to find your n. So, this is the first step, n. And then second step is the dot product, f dot n. And the third step is to find your limit. So the third step is to convert from 3D to 2D. So this dA means 2D. To solve the double integration, you can solve whether dy dx or dx dy. Both of these will give you a similar final answer. If you want to do dy dx, this means you want to do the integration with respect to y first, and then with respect to x. When you want to do the integration with respect to y, the limit is in the function of x. Y is equal to 0 and y is equal to 4 minus x. Okay, y from 0 to y equal to 4 minus x. And then x is from 0 to x is equal to 4. You want to do the integration with respect to x first, and then with respect to y, your limit must be in the function of y. So x equal to 0, and then you have to correct this. Y is equal to 4 minus x. So x is equal to 4 minus y. Here will be x is equal to 4 minus y. You can do the integration with respect to x first, and then with respect to y. So in this case, your limit of y is from 0 to 4. Both of these will give you the final answer 24.